Hi everybody! So in today's video, we're going to be going over some practice problems to help get us ready for the 5.3 Ready, Set, Go practice. So we're going to start with a little bit of a review of the three different types of writing the equation of a line that we've learned so far. So I want to start by reviewing slope-intercept form. Slope-intercept form is the name that we give to the equation of a line that looks like this. We call this slope-intercept form because in this equation, we can find the slope and the y-intercept of the graph very easily by just looking at the numbers. Now, one of the key things we need to know about this equation is that the y is always by itself. So in order for it to be considered slope-intercept form, the y is by itself. Another key piece of information is that there are no parentheses in this equation. The second type of equation of a line that we've learned about this year is point-slope form. Now, point-slope form of an equation of a line is the name that we give to an equation that looks like this. In this equation, we call it point-slope form because we can easily find the slope and a starting point on the graph, which in this case would be 1, 2. Now, in this equation, you will note that the y is also by itself. But this equation also has a parentheses, which is what sets it apart from slope-intercept form. Finally, we've been learning about standard form. Now, the standard form of an equation of a line is an example of an equation of a line that looks like this. In standard form, we don't usually find the slope and the y-intercept. The key features are usually the x-intercept and the y-intercept. So we learned about using the cover-up method. So to find the x-intercept, I would cover up the 2y, and I would imagine solving that equation. To do that, I would divide by 4, so my x-intercept would be 3, 0. To find the y-intercept, I would cover up the x, and I would imagine solving that equation. To do that, I would divide by 2, so my point would be 0, 6. Now, in this equation, the x and the y are together on the same side of the equal sign. Another important piece of information is that this equation will never have a fraction in it. And we want the x to go first and the y to go second when we put them together on the same side. Our target for today is going to be to use the properties of operations to take linear expressions and make them equivalent or determine whether they're equivalent. So we're going to be taking equations and rearranging them to look a little bit differently than how they started. A couple of the strategies that we're going to use today are in these two boxes. The first strategy is the idea of distributing. Distribute means multiply. So in order to get rid of this parentheses, I would distribute the -3, which means I get -3x plus 12. We can also use a combination of strategies by distributing and combining like terms. So this problem's going to have two steps: distribute and combine like terms. The first step here would be to just distribute. So in this problem, I would distribute the 2, which means I would have 2x minus 10. And I'm just going to drop down the 4. I'm not going to change it. I like to say drop it like it's hot. Next, I would combine the like terms. Now, in this problem, the 4 and the -10 are the like terms. When I combine them, 4 minus 10 makes -6, and then I would just drop down the 2x, so just drop it like it's hot. We're going to use these strategies and some of the other ideas that we've learned about solving and rearranging equations to do problems like this. For the first set of problems, the directions say rearrange the equation into slope-intercept form. Now, as a reminder, slope-intercept form means we want our equation to look like this. Y equals mx plus b, just like this equation up here at the top of the page. So we want the y on one side and everything else on the other side, and we want the x part first and the b, the number at the end. In the first equation, in order to make that happen, I'm going to start by getting rid of the x. I'm going to move the x to the other side. So I'm going to subtract x on both sides. When I do that, I get -2y equals -x plus 10. Now I still need to get y by itself, so I'm going to divide by -2. And in this case, I'm going to divide everything by -2 separately. Sometimes we would just write this like one big fraction, but slope-intercept form does not have one big fraction in it. So I'm just going to divide everybody separately. That means that I get y equals, and now I'm going to simplify each term separately. Right next to the x here, there is an invisible 1. So this really means -1 divided by -2. Now, -1 does not divide nicely by -2, but a negative and a negative, when we divide, do make a positive. So I'm just going to write 1 over 2, and then I'm going to copy down the x. Since the 1 and the 2 do not divide nicely, I'm just going to copy it down. Now, 10 divided by -2 does divide nicely. 10 divided by -2 is -5. So then I would simplify that answer, and this is my final answer. For problem number 2, again, my goal is to get the y by itself. So I would subtract the 3x on both sides. When I do that, I get y equals -3x plus 12. Now, once I've done that in this problem, that's all I need to do to make this equation look like this equation, y equals mx plus b. So for this problem, I'm done. Last but not least, for problem number 3, I've already got my y by itself, but the problem with this equation is that there's a parentheses, and slope-intercept form should not have a parentheses. So on the left side, I'm just going to drop down the y, and on the right side, I'm going to start by distributing. So I would have 4x plus 4, and then I would drop down the -6. Now I'm going to combine like terms. So the 4 and the -6 makes -2, and I would drop down everything else. Y equals 4x, just dropping these down. And now it looks like my equation is in slope-intercept form, so I'm done. Now, another type of problem that we're going to expect you to be able to do is to rearrange your equations into standard form. If we look back at the previous page, standard form was the type of equation that looked like this: ax plus by equals c. So in other words, we want the x and the y on the same side and the other numbers on the other side, and no fractions allowed. So for problem number 4, I'm going to start by getting the x and the y together on the same side. So instead of wanting y by itself, I actually want the x and the y to be together. So I would subtract the 1/2 x in order to get the x and the y on the same side. Now I want to write my terms in alphabetical order, so I'm going to write the negative 1 over 2x first. Then I'm going to copy down the plus y and the 4. Now in standard form, we don't want fractions. So what I'm going to teach you next is how do you get rid of a fraction since we don't want fractions. What you do to get rid of a fraction is you look at the denominator. If the denominator is a 2, we're going to multiply by the number 2 on both sides of the equation. Now, when I do that, I need to distribute. So 2 times negative 1/2 just makes negative 1x, and 2 times y just makes 2y. On the other side of the equal sign, 2 times 4 makes 8. And this would be my final answer. The x and the y are together, and there are no fractions. Next, for problem number 5, again, we want the x and the y to be together, and we want no fractions. In this problem, the x and the y are already together on the left side. The issue that I see is that we have a fraction. So once again, we're going to focus on the denominator. If your denominator of your fraction is a 3, we're going to multiply by 3 on both sides. So if I distribute, 3 times 2/3 would just be 2x. 3 times 4y would be 12y. And 3 times 8 would be 24. And that would be my final answer. Last but not least, in a problem like number 6, so again, we want x and y together on one side and no fractions. In this problem, I'm going to start by distributing. So I'm going to distribute the negative 2, which means I get negative 2x minus 2. And I'm going to drop down the y, and I'm going to drop down the minus 5. Now I'm going to combine like terms. So if I combine the negative 2 and the negative 5, I get negative 7. And I'm just going to drop down the y and the negative 2x. Now I need to get the x and y together on the left side. So I'm going to do plus 2x on both sides. And that's going to give me 2x plus y equals negative 7. Now, one of the key things here that we need to be careful about is to read the directions. Reading the directions is going to be very important. So on the test that I give you, it's not going to be nicely separated where here's all the problems where you want slope-intercept form, and here's all the problems where you want standard form. Instead, it's going to look more like this. Problem number 7 says rearrange into slope-intercept form. We need to know that slope-intercept form means y equals mx plus b. So to make this equation in problem number 7 look like slope-intercept form, the first thing I'm going to do is I'm going to subtract the x on both sides of the equal sign, which means my equation will be negative 4y equals negative x plus 28. Now I'm going to divide by negative 4 on both sides, and I'm going to divide everybody because I don't want my final answer to have a big fraction in it. So I'm going to get y equals, the invisible number by the x is a 1, and 2 negatives make a positive. So I'm going to get a positive, and since 1 does not divide nicely by 4, it would be 1/4 x. Now 28 divided by negative 4 does divide nicely, and I get negative 7, and that would be my final answer. For another example, the next problem says rearrange into standard form. Now standard form was ax plus by equals c. So that means that I want the the x and the y together on the same side, and I want no fractions. So what I'm going to do here is I'm going to subtract the 1/5 x on both sides in order to get the x and the y together, which means I get negative 1/5 x plus y equals negative 8. Now I need to get rid of that fraction, so I'm going to look at the denominator and I'm going to multiply everything on the left and everything on the right by that number. So when I multiply 5 times negative 1/5, I get negative 1x. When I multiply 5 times y, I get plus 5y. And negative 8 times 5 would be negative 40. We're going to go ahead and save problem 9 for when I see you again in class. Thank you all so much for watching and have a wonderful afternoon. I will see you for some practice problems tomorrow.